Hello everyone, I am No-3 and we are in a lecture series of dynamics of machinery, and this is the lecture number 3rd. In previous two lectures we have seen the Porter-Governor derivation and problems on Porter-Governor, and now this is the second problem. So let's discuss what is the statement. The arms of Porter-Governor are each 250 mm long and pivoted on the governor axis. The mass of each ball is 5 kg and mass of central sleeve is 30 kg. The radius of rotation of a ball is 150 mm when sleeve begins to raise and reaches a value of 200 mm for maximum speed. Determine range of governor if friction at a sleeve is 20 Newton. So in this problem, the friction at sleeve is given as a 20 Newton and we have to consider that friction. Determine how speed range is modified. So in this problem we have to first find out range of speed without consideration of friction, and then we have to consider friction, and again we have to calculate range of speed, and that range of speed is nothing but your modified range of speed. So according to the given data, mass of the each ball is 5 kg, mass of central sleeve is 30 kg, and frictional force on the sleeve is given as 20 Newton. So let's solve the problem, and here it is our figure. You have to draw both the figures, first indicating the minimum position and second that is indicating your maximum position. For minimum position, your radius of rotation is 150 mm when sleeve begins to raise, yes, and reaches a value of a maximum position at 200 mm. So according to these, we have drawn there two minimum position, maximum position schematic figures. Here it is your H2 and this is your H1. So 250 mm long. So arm length for governor is given as 250 mm each. So both arms are equal. So we know if both arms are equal, then value for Q is equal to 1. Tan beta by tan alpha is equal to 1. Here it is the FC, centrifugal force acting on each ball, mass of the ball mg, mass of the central sleeve mg by 2. Why it is mg by 2? Because we have considered only half section. Okay, now we have to solve the problem with assumption of a case 1 without consideration of frictional force, and case 2 is with consideration of frictional force, that is given as a 20 Newton. So first solve without consideration of frictional force. So if we want to calculate H1, how to calculate H1 is the first task. This is my H1 and this is my right angle triangle. If you are consider this triangle is a right angle triangle, so apply the Pythagoras theorem over here. That is nothing but H1 square is equal to 250 square minus 150 square. If you take the square root, you will get H1 as 200 mm. So this is the final answer for H1, means H1 is 0.2 meter. And how to calculate N1? Similarly, we can calculate N1 because we have the expression for N1 square, that is getting from first lecture. If you have not watched that lecture, you can go through that lecture series of first lecture, lecture number 1, where we have discussed how this expression comes with the help of the derivation. So N1 square is equal to 895 by H1 inside bracket small m plus capital M divided by small m. And after simplification of these, just you have to put the value of H1 over here, that is 0.2 meter. 200 mm, that is 0.2 meter. You have to put the value of H1 over here, 0.2 meter. You have to put in terms of meter only, not in mm. This is mass of the ball 5 kg, mass of the central sleeve 30 kg, and this 5. So if you calculate this and take a square root, you will get N1 is equal to 176.98 rpm. Similarly, you have to apply same for maximum position. You have to similarly calculate H2 over here. This is your H2. How will you calculate H2? Here it is a Pythagoras triangle and you can apply Pythagoras theorem for this. So H2 is equal to 250 square minus 200 square, because the length of the arm is 250 mm and radius of rotation now going to be changed from 150 to 200 mm. So 250 square minus 200 square. Yes, and here it is, you will get H2 is equal to 150 mm. That is nothing but 0.150 meter. Yes, now similarly, you have to calculate N2, that is nothing but N2 square is equal to 895 by H2. Same expression you have to apply. You have to just put here value for H2, and that is in meter, 0.150 meter. After calculating, you will get N2 as 204.36 rpm. Now, what will be the range of speed? Range of speed is the difference between N2 minus N1, and that is 27.38. That range of speed is nothing but without consideration of friction. We have not considered here friction. Okay, so you have to remember this. Now we have to consider case 2. And what is case 2? With consideration of frictional force, and frictional force is given as a 20 Newton. And here we can use previous data. H1 we have calculated 0.2 meter for that. Okay, this is my sleeve now on a spindle axis. Now sleeve is moving towards the downwards. What will happen? Frictional force will act upward. Lecture number 2. Okay, the concept already we have talked in lecture number 2. You can see there the total weight of the sleeve acting downwards, mg, w is equal to mg. So net when sleeve moves downward, total force on the sleeve. How to calculate total force on the sleeve? W which is acting downward minus that of the F which is acting upward, both having opposite signs. So W minus F. So W is nothing but mg minus F. Okay, sleeve weight, that is mg. Now N1 square. This is the required expression. With the help of derivation we have seen this expression, how we have calculated this expression. So we have an expression mg plus w minus f divided by mg into 895 by h1, and here we use h1 as the previous data. We have calculated h1. Just put mg plus mg minus capital mg minus f. So w stands for capital mg. Okay, so don't forget between small mg and capital mg. This is the mass of the weight of the small balls. This is the weight of the sleeve. Okay, divided by weight of the ball into 895 by h1. So put here n1 square. So put here n1 square is equal to 5 into 9.81 plus 30 into 9.81 minus f. Why minus f is there? 20 Newton is given. So into 895 divided by 0.2. We are using here 0.2 because we have calculated h1 value as 0.2 meter. After simplification this, putting all the data, you will get n1 is equal to something 171 rpm. Now we have to calculate n2. How we will calculate n2? Now your sleeve is moving upward. You have to consider when sleeve moves upward, your sleeve is going to move upward. The frictional force is acting downward. Why frictional force is acting downward? Because opposite to that of the motion, frictional forces exist. So here frictional force acting downward, here total weight of the sleeve is also acting downward. Both directions are same, so we can sum it. So total force on a sleeve W plus F, that is mg plus capital F. Now just simplified here formula. We have here use minus. Now what we have get? Mg plus F. So just replace that minus into a plus sign. So mg plus F. Rest of the formula is the same. So after calculating and putting the values, you will get same different answer. Why? Because here h2 value is 0.150 meter. We have calculated already h2 is 150 mm. That h2 you have to put over here. Okay. So after putting the h2 0.150 meter, you will get n2. Just what is different here, putting the value of h1 and h2, you have to use previous data that we have already calculated, and that previous data is nothing but here. Look at here, we have already calculated here. H1 is a 200 mm and h2 is a 150 mm. You have to use that that data with n1 calculation and n2 calculation with consideration of frictional force. Here we have used h2 as 0.150 and here we use h1 as 200 mm, that is 0.2 meter. Okay, after calculating this, you will get the answer n2 is equal to 210. So if I want to calculate the modified speed range, that is nothing but n2 minus n1. So that is 38.48, because n1 we are getting with the consideration of friction as 171 and n2 is this. So this minus this, you will get 38. So this is modified range. Thank you for watching my channel.